Hi everyone. Let me start by thanking our host Paul for having this roundtable again this year. We're happy to be here. I'm Gil Elizov. I'm VP Product at Gilat, and I will talk today about ground and space harmony in the new Elastix Space Era. As we all know, as we all see around us, more and more satellites are being launched every day. NGTSO and GEO VHTS satellites are part of reality. More and more capacity in satellites are being added, changing our segment of satellite communication and allowing much more user and much more application to share it. New technologies in LEO and in apps even are allowing much more capacity and user than ever before, and this is a change that impacts the entire industry. As more and more satellites are being launched and more capacity is being added to the satellite world, the price of services is dropping, and the cost per megabit of a service today is much lower than it was in the past, and it will continue to decrease as more and more satellites will emerge. Those new satellites are actually a software-defined satellite by most of them, which means a new type of satellite which are much smarter, where an harmony between the ground and the satellites is crucial in order to allow new types of applications and new type of services to emerge and to enable satellite operators to reach new segments. All of that is based on moving into the cloud. Cloud-based ecosystem is part of the reality of the satellite operators and part of the technology that we are all emerging in the different products that we have. On top of that, having more and more capacity, aiming for new kinds of segments and application requires the access to be much more flexible, much more elastic than before, with much better efficiency than we used to have, and I will touch that also later on. As I mentioned, we are seeing more and more orbits and more types of satellites adding to those orbits, which actually leads to a multi-orbit environment. LEO, MEO, and GEO type of constellations is not a standalone constellation. At the end of the day, the application and the need is to have a seamless handovers between satellites on same orbit, but also between satellites on different orbits. And the needs in applications today becoming more and more critical to have a multi-orbit solution. If you look on in-flight connectivity, maritime, at the end of the day, there is a need to have a constant connectivity for multi-orbit, where each orbit brings its own values into the game. There is a need for the GEO, there is a need for the MEO, there is a need for the LEO, different applications, different requirements, and we are required to support all of that and allow a seamless multi-orbit environment. The software-defined satellite, as I mentioned earlier, is creating a new challenge of how to create an harmony between space and ground. When the satellite is smarter and can be controlled from the ground and have multiple variants of the satellite change on a minute-based or even seconds-based, the ground segment must cope with that and must allow the satellites to enable that change. The network on the ground needs to be aligned with the satellites and to allow those changes. It means that there is a constant connection between ground and satellites, and changes are being deployed on both of them simultaneously in order to enable much wider variety of services and applications than we used to have in the satellite communication. This brings the need for a new type of access schemes, a new approach for access scheme that will allow this flexibility, multiple type of application that varies from low bit rate to high bit rate, from moving into a fixed solutions in one hand, and in the other end to allow much higher numbers of terminals than before sharing those bandwidths. Elastic SCPC and a TDMA is a must in those kind of environments in order to allow services of the various applications over those new type of satellites. Efficiency is crucial. We in Gilat introduced a new type of access scheme and a coding algorithm that allows us to have 15% better efficiency than previous systems. We increased our return capacity to allow links that up to 750 megabits in order to be able to cope with the variety of applications that are out there, and to allow 500 megasymbols of a channel in order to be able to cope with all those demands from various types of applications and the increased capacity that comes from those new satellites. All of that at the end of the day needs to sum into an architecture that is flexible, that can support any kind of satellites in any band, in any orbit, in any number. All of that needs to be connected to a ground infrastructure, starting from a data centers that can be cloud-based and can be populated in various places around the world based on the needs of the end customers and the service operators. The gateways must be smarter. They need to support multi-type of beams, different type of bands, different orbits, and allow connectivity from any kind of data center to any kind of gateway to any kind of satellite. The networks are growing, the capacity in those networks are growing, and satellite operator requires the ability to deploy gateway wherever they want and with any size they want. And at the end of the day, all of that needs to be orchestrated by a single management system that needs to be able to connect into a resource manager that controls everything, the satellites and the ground, and creating one big harmony of the entire satellite network. On top of that, moving into the cloud becomes crucial. Moving into the cloud for basic things like management and operating systems of the OSS PSS part, but also in the data center, there is a need to move into the cloud, and of course on the gateways itself. At the end of the day, the goal of the market and the service operators is to have a fully cloud-based system like in other industries, terrestrial and cellular. The density and the scaling that is required in those big networks with a lot more capacity than before and software-defined capabilities on the hub and on the ground mandates all of us to move into the cloud, and this is part of the future that we can see in all the vendors' equipment. Once everything is in the cloud and we have multiple type of orbits and we have smarter satellites, all of that needs to be managed by a single orchestrators that manage the ground and the space. All of that needs to be part of a big cloud network. This all brings the need into an harmonized networks that can be deployed on multiple gateways, multiple satellites, multiple applications, managed as a one global cloud that manages the entire system. Each operator today, from the big one, is building those kind of networks. If you look on all the big players, everybody is moving in the same direction. Orchestrator, cloud-based system, and a network deployed all over the world. We cannot talk about those new types of technologies and new type of satellites without looking on the 5G NTN. The 3GPP is looking into the satellite industry in the last few years and starting to build its releases to meet also the satellite segment. We are today at the end of 2023, beginning of 2024, seeing this path of the 5G NTN emerging. Release 17 that was released last year, we are starting to see the first type of application and chipsets coming, was aiming mainly for the narrowband IoT application, but it's the first step in a multi-year approach, multi-releases approach of the 5G NTN by the 3GPP to add to the satellite segment also a 5G waveform. Next year, the release 18 will be formalized, and following that, we will start to see by the beginning of 2026, maybe even earlier than that, new chipset that will support the capabilities of the release 18, which means higher throughput, transparent satellites, and even hybrid networks of 5G and standard DVB networks. Later on, release 19 will come that will address the regenerative payloads on OBP satellites, as we see a lot of those satellites coming mainly in LEO constellation, but not just there. So release 19 will also address that, and by 2028, most likely we will have chipsets that address that as well. So there is a clear path from the 3GPP to standardize the satellite world and bring the 5G waveform and capabilities into the satellite world. So how all of that will play together? When we at Gilat look about 3, 4, 5 years from now, we see one big network that needs to deal with everything that I said so far. It needs to deal with multiple orbits, it needs to deal with multiple types of satellites, a lot more throughput, smarter networks, software-defined networks, and cloud, and also different type of access schemes. if it's a DVB-based access scheme, if it is a proprietary kind of access scheme, or if it is a 5G kind of access scheme. All of that needs to reside over the same networks. And the reason is very simple. First of all, satellite operators today already have invested in deploying certain applications with certain waveforms and certain capabilities. This cannot go away. This still needs to be supported. New access scheme and new capabilities are emerging every day, and we need to deal with that as well and give it part of the network. And also 5G, as I said earlier, 5G NTN is becoming reality. We are starting now with IoT-based application, but as we go along, in 2-3 years, we will start to see it coming to other type of application with increased bandwidth and increased capacity. And it's all need to be part of the same network. At the end, the satellite operator will need the ability to deploy the relevant access scheme over its network, over its cloud network. So we will have at the end the existing deployments. We will have at the end new type of virtual deployments of existing waveforms. And we will have at the end also 5G deployments, which are also virtual and over the cloud, like a G0B of NTN on the cloud. All of that we need to reside in the same gateways, in different gateways, based on the needs of the satellite operator. We need to bring to the satellite operator the capability to run with any kind of access scheme that is out there. The data layer, at the end of the day, will be a common data layer, because once we move closer and closer into 5G NTN and deploying that, we will connect the data center into the 5G core. And part of the satellite network will be also part of the 5G core of the terrestrial network, which means that at the end of the day, a satellite network will have a multi-waveform, multi-orbit, multiple architecture deployed in parallel in order to meet the various type of applications that are out there. Because as we can see today, in-flight connectivity, maritime, cellular backhauling, enterprise applications, there are different requirements on each one of those applications, different capabilities and different needs. There is no one thing that meets everything. We need the ability to adjust and to have multiple type of waveforms and architecture in the network in order to meet all these application capabilities requirement. And as we will move forward and the prices of the capacity will drop, we will see new kind of application emerge that will have different requirements. A multi-waveform kind of architecture is the basic in order to move forward and allow the best flexibility for satellite operators. So thank you for listening to me for this short review of how we see the market. There is a lot of new technology coming and a lot of new challenges that are coming into the satellite world that I'm pretty sure we will be able to meet them and to move forward. Thank you.